We're going to be taking some time to look again at the discriminant of a quadratic equation, which is the b squared minus 4ac part of the quadratic formula. The value of the discriminant indicates the number and types of solutions for a quadratic equation. So based on what we get for the discriminant, we can determine how many, either one or two solutions, and whether the solutions are rational, irrational, or non-real complex. If you think logically about what's taking place in the quadratic formula with the discriminant, these correlations make a little bit of intuitive sense. Recall that the discriminant is the part that's under the square root. Well, if we get a positive value inside of our square root, that's the only way that we're going to get real numbers, okay, as well as with zero. Any non-negative value will give us something real. But when we square root and we get a negative value, that's when we get non-real solutions. Now, because the square roots always have a plus and a minus, that's why we often get two solutions, when we add the square root and when we subtract the square root. The only difference is, if I add or subtract the square root of 0, which is 0, it only gives us one result, because subtracting 0 makes no difference whether we add or subtract, and that's the only time we have one solution. Now, whether or not it's rational or irrational comes by whether or not we can take the square root. If I have the square of an integer, such as a number like 25 or 36 or 121, these are all numbers that I can square root and I get an integer value. So if I can take the square root and get an integer, then that means I can add and subtract integer values, leaving me with rational solutions. But if my discriminant is not the square of an integer, such as 37 or 24 or 120, these values I can't get a square root for. I get an irrational or an approximate value for any of these. And therefore, when I add or subtract them, I get two irrational solutions. The other thing to note is that if our solutions are rational, these are the only times that our quadratic is factorable. And it's a good thing to note whether or not the quadratic can be factored. So we can use the discriminant to predict the number and types of solutions for each equation and determine whether or not the quadratic could be factored, or if we need to use the quadratic formula. So we're using our formula b squared minus 4ac. And so we go ahead and plug in our values. B is -1, A is 6, and C is -15. So we substitute those values in, and we evaluate and get a value of 361. 361 is 19 squared, which means we have a perfect square. Since it is a perfect square, or the square of an integer, then that means that we will have two rational solutions. So the value of our discriminant is 361. We have two solutions. They are rational. Because it's rational, it means that the quadratic is factorable. Take a look at the next. Just like with quadratic formula, it needs to be in standard form first before we can apply our formula for the discriminant. But once it's in standard form, and we substitute the values in, we can go ahead and evaluate it, and we get 76. 76 is positive, but it's not the square of an integer. Therefore, we get two irrational solutions. Because they're irrational, we would have to use the quadratic formula. C is in standard form. B squared minus 4ac. And we get a value of -191. Because the value of our discriminant is negative, we get two non-real complex solutions. And because they're non-real complex, we have to use the quadratic formula. Standard form, we plug in our values for b, a, and c, and we get a value of 0. This will be the only time we get one solution. It will be rational and factorable. And not only is it factorable, it also means that it is a perfect square trinomial. And it's actually factorable using our formula to get a binomial squared. Now we can use our information about the discriminant to answer questions based on certain criteria. We want to find the value of k so that we'll only have one rational solution for the quadratic. That means our discriminant has to equal 0. Well, if we substitute the values that we have, we can go ahead and solve for k. When we square root both sides, we get a positive or a negative 12. So k could be either 12 or negative 12, and then our quadratic would have only one rational solution. If we want the greatest integer value, then our discriminant has to be less than 0 in order for it to be negative for no real solutions. So we substitute our values in that we know. And we find that k squared has to be less than 0. Sorry, not 0, 10, 100. So when we take the square root, because we have an inequality, we can get our positive root as normal, but when we take our negative root, we have to flip the inequality in the opposite direction. So k has to be a value less than 10 or greater than negative 10. So we need to find the greatest integer value between negative 10 and 10, which would be the number 9. K has to equal 9 in order for us to have no real solutions.